Before we start 12.1b, I want to highlight a few things. The AP board does give you an exam tip about parameters. The AP formula sheet actually shows y hat equals b naught plus b1x. But in the book, they use y hat equals a plus bx. It doesn't really matter on the notation. Just be careful. Know that the y-intercept is here, so b naught is on the formula sheet. We reference a. It's the same thing. The B1 is on the formula sheet, but we just call it B. So just be careful to keep those straight. Now, this is actually a review type of vocab word, but it's a little bit different for a linear regression. We talked about the standard deviation of the residuals earlier, where it was the letter S. And what we did for standard deviation of the residuals is we took all the residuals and squared them and then added them up before we divided by n minus 1. Because this is a linear regression and we have two variables, the only adjustment is when they record S this time, it's going to be divided by n minus 2. So keep in mind if you forget how to find a residual. The residuals, remember, are observed minus their prediction. So what observed value did we actually get? That is, what was the actual test score for a student, minus what would the model predict. Take that residual again, square it, add them up, and divide by this, and then take the square root to get standard deviation. What exactly is this going to tell you? First, remember again residual. Residual estimates how much y varies about the population line. This right here is our residual calculation. Our population line is y hat, so it's how much we vary. Another word for residual is just how much error is in the model. So understanding what residual is, therefore, we can say, what is the standard deviation of the residuals? It describes the typical prediction error that you're going to get. So if you're going to use your model to make a prediction, your model will have some error. The number that this ends up being is the typical amount of error. Another thing to quickly recall about this, though, is what unbiased statistic means. Remember, unbiased means the mean of the sampling distribution statistic is equal to the value of the actual parameter. So in this case, if I were to take the means of all of the slopes, if we're thinking about our test data, the mean or the average of all the slopes in that sampling distribution, which is this right here, should be close to the true population's slope, which we define as capital B or beta. Let's look at 12.1b, which is interpreting computer output from a least squares regression analysis. Now, I will tell you, of the questions I've seen for Chapter 12, a lot of them have to do with interpreting the computer output and making some decisions. Let's first look at question A. State the equation of the least squares regression line. Define the variables you use. Remember from Chapter 3, this gave us the least squares regression line. So the constant is our y-intercept. The value or the word that's listed is our slope element. So this is the slope for our explanatory variable. So on this, the least squared regression line that I have, if I use x and y, I would say that y hat is our y-intercept and then our slope times x. Let's define the y hat as the predicted score and x is the row that you sit in. Now for part B, we've already interpreted the slope and the y-intercept. So let's just go ahead and I'll show you those answers again. We did that on a previous lesson. Remember, the slope talks about for every row from the front, our test score will go down by 1.1171 on average. The y-intercept, if you're in row 0, it is what your test score will be, but no one sits in row 0. Now our new vocab word is going to be the standard deviation of the residuals. Where you can find the standard deviation of the residuals is going to be right here. So this here is considered the standard deviation of the residuals. So I'm going to do this little arrow. That's the S for our particular model. Let's define that in context. What it means is this. We can say that the standard deviation of the residuals is when we use the least squares regression line to predict test scores from a student's row number, it will be off by about 10.07 points on average. Overall, it's how much error the model is going to have if we use it. A few other key components to review and some new ones to highlight. R squared, this is our coefficient of determination, and that's what we'd use. Remember, take the square root of it and then determine if it's plus or minus for R or correlation. We completely ignore the r-squared adjusted. You will never use that. Now for chapter 12, we're going to be analyzing elements about slope. Because slope deals with, if you think about it, the change in y over the change in x. So it's rise over run, or it's one quantitative variable over another quantitative variable is what slope is. So if we analyze slope, we're actually analyzing the impact or the association between two quantitative variables, is what chapter 12 is all about. So what we do to find the test information for that is you go to the slope and you just scroll across like we would for any other variable. This right here is actually our test statistic for the slope, and we'll talk about that a little more in detail. This is the p-value, or the probability of, given our h sub o is true, that our statistic will happen. That's the p-value for the slope. This here is a new vocab word we'll talk about. It's the standard error of the actual slope itself. And let me show you on the next slide what the actual formula is for the standard error of the slope. And make sure you keep it straight from the standard error of the residuals. So let's dive into this. The standard error for the slope has a little sub b on there to help keep it straight. And what it is the standard deviation of the residuals divided by the standard deviation of the x values only, and then you times it by the square root of your sample size minus 1. I've never seen the AP board ask you to calculate this. I have seen them giving you this information, ask you to interpret in context. So do know one, it's on the formula sheet. So if you need to do it, again, standard deviation of the residuals, standard deviation of x, and then our sample size. What does it mean in context though? What it does is it measures how far we expect our estimate of the slope to be from the true population parameter and repeated samples. It's basically how much error we're going to have if we use our model for predicting our slopes. The AP board also talks about this common mistake that is worth pointing out. It says here when students interpret the slope, they often forget to include the idea of average. Remember, average or predicted acknowledges that our predictions are not guaranteed to be correct. If we use a least squares regression model, we're making a prediction. So it's on average what we would expect to have happen, because that least squares regression model was computed from one particular sample. And it could be a slightly different model if we used a different sample. So it's on average what we would think would happen.